In 2020, 3 rovers, one from the US, one from Europe, and one from China, will leave Earth and depart for the red planet of Mars to look for past and present life. And these rovers aren't just going to go to Mars. They have in their mission directorate to bring back samples from the red planet to Earth, which is going to be one of the most influential launches and landings and science experiments of human history. Parts of Mars, directly from the regolith of Mars, will be returned to the planet Earth. So scientists on Earth, with really sophisticated instruments, can study what's in the ground on Mars. So the rovers will be sent up in 2020 and they'll land. They'll do science and they'll cache the samples for a return mission for Mars, from Mars, and they'll return to Earth in 2028 if America and Europe come together and make the mission a success. But a project scientist on the ESA rover ExoMars that will land in 2021 along with the American and Chinese rovers might be worth reconsidering which samples would actually be the best valuable to send back to the scientists waiting on Earth. And this scientist said Mars 2020 will acquire samples from the surface where ionizing radiation is likely to have damaged any organic molecules. It is ExoMars, with its 2-meter depth drill, an advanced organics detection instrumentation, MoMA, that has the best chance to make an important discovery regarding the possibility that Mars may have harbored life in its distant past. If this proves to be the case, perhaps we may need to rethink whether we should not think of bringing back well-selected subsurface samples rather than those collected by Mars 2020. In the Mars 2020 rover, which is a NASA rover, it has the ability to cache the samples that it gets. But ExoMars does not have that capability for a return mission later on. And he goes on to say that requires a complicated setup that weighs a lot. It would have been impossible to combine our present very capable payload with a sample caching system on the same rover. In fact, NASA's 2020 rover has paid a dear price to include the caching system, and that's compared to Curiosity's analytical firepower. So what they gave up in analytics and studying the actual surface of the planet Mars, they gained a caching system. So instead of doing the science on Mars itself, what they're doing is putting it away for a little while, and they're using that space to harbor those samples. Then they're going to return them to Earth on the Mars 2020 rover. And then George Vago goes on to say, the point I am trying to make is that bringing back the right samples will make all the difference. In this regard, ExoMars will be super important. Are the samples collected at depth more interesting and better preserved? We think probably yes. And once we will have investigated this, perhaps it will be time to rethink what samples to bring back to Earth.